Hey guys, welcome back to my channel, and today we're going to be talking about continuity. So continuity is a topic that you'll see a lot in Calculus 1, and it's basically, as the word suggests, continuity means continuous. So it is continuous, so a function that is continuous at every number in the interval. So if it was negative infinity to infinity, then it would be continuous in the interval from negative infinity to infinity. So that's basically what continuity means. And when we're given a function, to determine if it's continuous, there's a certain rule that we use. And the rule is, there are 3 steps to this rule. So I'm just going to erase this and do it on the new page. So 1, the function. So when you plug in that number that you're asking if it's continuous, for example, there could be a question like determine if it's continuous at this point. So first you would plug that in. So f of a, whatever that number is, should exist, is defined or exist. Okay? So that's the first part of continuity. The second part is that the limit as x goes to that value a that you're trying to see where it's continuous at, that a that it's continuous at, f of x exists. And remember, from my previous limit videos, I talked about how when it goes from it only exists if it is the same number from the right side and from the left side. If they're equal to each other, then the limit of x to a, f of x, would exist. And then 3, this is the main step, so this is the most important. F of a should equal the limit as x goes to a, f of x. If this is not true, then it's discontinuous or not continuous. So I'm going to give 2 examples or 2 practice problems, and then that's pretty much it. Continuity is pretty straightforward. So for this, x squared minus x minus 2 over x minus 2, and this is the function f of x, so I'm going to write that. Sorry, I didn't write that in the beginning. So in this situation, this is x squared, just remember that. Alright, so we're trying to determine if it's continuous. So first of all, as you can see, whenever you have a denominator on the bottom, it's most likely not continuous at that point, because this part can never, this is what I meant. This part can never equal 0. So if any value can make this 0, because remember, a number over 0 is undefined or not defined. And if that's the case, then this is discontinuous, and that is the case. At x equals 2, this function will be continuous. So therefore, it is a discontinuous function that is not continuous. Right? Now here's another example. So let's say we have f of x equals x square root 20 minus x squared. Now, 20 minus x squared, this is a function. Now what we have to do is to determine, so the question is determine if it is continuous, if it's continuous. I'm just going to write CONT and then put a dot continuous at x equals 2. Okay? So that's what we're trying to determine. So first, what was the first step? You need to just figure out if f of 2 is defined. And so f of 2, when we plug in 2, we get 20 minus 4, which is square root 16, and square root 16. You get basically 2 square root 16, and square root 16 is 4. So 2 times 4, which is 8. Next part, or the second part, is to determine if the limit exists. So the limit from the right side and the left side. So here it's just a function. So it's just the limit as x goes to this value 2, f of x, which is x 20 minus x squared. We don't need to cancel anything, and obviously it would equal 8, because when you plug in 2 for all these values, you'll get the same number. 3 is to check if this value and this value are equal to each other. Basically, is 8 equal to 8? Yup. So therefore it is continuous at x equals 2. And in reality, it should be continuous from any point above 0, because sorry, any point from negative infinity to infinity, it should work. Because if you think about it, if I plug in a negative value here, it's still going to be positive, so you have no issue, right? All right, so this video is actually really short because continuity is very simple and to the point. Thank you so much. If you have any questions, put them down below, any topics you want, and thank you so much, and goodbye.